Okay, so let's give like at least 1 minute for the attendees to come in. So we'll just wait a bit more. All right, okay, let's go. Okay, hey everyone, wherever you are, welcome to Algo HackJam's technical workshop 3. It's on building smart contracts with PyTeal. So let me start off by introducing our speakers for today. They are Ryan and Russ from Algorand Inc. So super happy to have them here today. So I'll pass this on to Ryan to share his screen to share a little bit more about the session.
All right, looking forward. All right, here we go. Let's share this up. My turn to share my screen is now. And I will get to this one. Hello and welcome everyone. My name is Ryan Fox. I am a developer advocate here at Algorand. Welcome wherever in the world you are. I'm joined by my colleague, Russ Festino. We are actually both here in New York this week doing events associated with NFT NYC. This is that's me before I came to Web3, working at a mortgage bank 5 years ago, and now you can see after what I look like here in Web3. So if you want to connect with us, make sure that you reach out to us either on Discord. You can see my handle up at the top, or follow us, the Algo Devs. And if you want to reach me directly, I am Ryan R. Fox on nearly all of the social media platforms. So why are we here? We are here, of course, to build. We know that you are participating in the Algo HackJams, and for that, we thank you. We want to help you succeed in your build. And as a developer advocate, Russ and I are here to help you along in that journey. So as I go through my presentation today, Russ is going to be available in the chat. So whichever platform you're joining from, use the chat feature in there, ask your questions as I go along. Russ will message you back, and certainly he will be able to interrupt me and surface any questions as we go through. So let's do this, builders. What are we going to do today? Well, we're going to take a look first at some resources so that you know how to successfully navigate the Algorand developer resources. We'll show lots of information for you so that you can get in there and start building quickly. We, of course, will help you set up your development environment. It's very important that you understand how to get your environment set up, and we'll take care of that, as well as ultimately go through a demo of the PyTeal language and building out a smart contract using our application binary interface, or ABI. So we'll see that. All right, I know that you guys have been in crypto for a hot minute, and I'm sure you have seen this before. When Moon? Well, I know that you as developers hate when some old guy comes up here with his PowerPoint presentation and you just sit there and yawn. So let's skip to the end and let's figure out what we are actually going to see. So if I show you what we are going to do, it looks like this. Oh, I have to move out of the way. Yes, let's move this down here so that Zoom is out of my way. All right. What we're gonna do today, we're going to go through this demo, and what this demo is going to allow you to do is to design a smart contract using our PyTeal language, and it once you compile that, is going to generate a teal program. Ooh, that looks a little bit hard. Don't worry, we can skip over that. And it's also going to generate this JSON file, which describes the ABI. And again, that's an application binary interface. This allows machines and humans to interact. So we'll have an application that will be able to consume this JSON file and build. Oops, I should copy that so I could actually show you. Oh, too many side things. Let me just hit Control A, copy. And then we have this user interface here that we can take that JSON file, pop it in here, and scroll to the bottom. And I got to move you guys out of the way so I can minimize you guys so that you are out of my way. And then come down here and submit this. And what it does is it takes that JSON object and it actually creates the interface, the user interface, based on that interface file so that we can actually do some cool things. So what our smart contract is actually going to do is a series of math and string operations. Here, this first one is add. So let's do 1 + 2. And when we hit this, it's going to send a transaction to, don't query, run it. Did I not configure this right? Oh my goodness, people. The demo gods be with me. You're supposed to config, use, there we go. Okay, current. Now we have it turned on. Now we can query it. Put this down. And we will see that, in fact, yes, the result of this transaction, which is an application call transaction to the blockchain, adds a 1 + 2 and gives us back a result of 3. So that's what that ABI allows us to do. It describes that one input value is a UNT64, the second input value is the same, and then it is going to return a UNT64 as well. So that's what we've seen. So let's figure out how we build it. So now we go this way again and we get back here. What we're going to do is we're going to start out with resources. We want to make sure that you have the bits that you need and know where to go in order to find information as you build. The first place that you are going to go is going to be the Algorand developer portal. We have this award-winning website at developer.algorand.org. You hit that QR code if you're on your mobile, no problem, we'll get there. Let's take a look at what that looks like. The Algorand developer portal is your source for all things Algorand as a developer. We've got it organized into some topic areas where you can jump in. Across the top, we have it organized by docs so that you can jump in and quickly begin getting started. Down the left-hand side, we have this getting started section along with get details, which goes into more and more details about building smart contracts. We can also take a look at the various SDKs that we have here. We're going to be focused on Python, but we also have it available in JavaScript, Go, and Java. We have our REST APIs documented here so that you can understand what those endpoints look like and how you would interface with the blockchain. And then we also have reference documentation for our command line tools. We'll see a little bit of that. And then if you are interested in running your own node, you can do that. We're going to see how to do that with Sandbox in a little bit. All right. We also have a whole lot of articles for you to learn how to build and to connect with our community of developers who are putting out their own set of content for solutions, which have code that also teach you how to make smart contracts. Many of them are tutorials that you can walk through, check out the code, follow the instructions, and you'll be building quickly. Up here at the top for tools, this is where we have our ecosystem tools and projects. We are definitely going to take a look at some of the IDEs. We have all, so up here, we just have it broken down by all the different things. We'll take a look at the IDEs and the SDKs, but there are also lots of different sections here where you can take a look at the applications that people are building and how to interface with them. Make sure you get yourself the Para mobile wallet here. So if you've got your mobile, you can use the Para mobile wallet. Or if you are online, you can use a cross-platform browser-based wallet called MyAlgo, as well as the Algo Signer is a wallet that is built into the Chrome web browser for that. So lots of great resources here for you if you're interested to see kind of what's going on the Algorand mainnet. We've got all sorts of transactions happening, lots of addresses, a million, 150 million in total locked value. Plus, you can check out what's going on with our developers as well. The other thing that I will make you aware of on the developer portal itself is this link to the Discord, which is I'll show you a link for that. But that's where we connect. Let me just go there. So I've got my Discord over here, and we've got all sorts of various connections for you as a builder. Oh, come on now. Well, we've got a screenshot of it on another thing, so we'll come back to that. All right, back to our presentation. I want to show you, yes, this is the link for that Discord. So as you saw, you can click on it in the dev portal in the upper right hand corner, or you can get to it here. But here we have channels available for all of the various tools that we have. We're going to see Sandbox. If you have a question about that, you can jump into there. We're going to be dealing with the Python SDK. We have a channel for that. There's also one for PyTeal, so that's something else that we'll be working with. If you're building smart contracts, there's a channel specifically for that. There is a channel for whatever you want. Russ, myself, the rest of my colleagues are in here nearly around the clock. I tell you, our colleagues, Nullen and Barnji, seem to never sleep. They are there to help you. I believe there's also a Discord server for the HackJam. You can use that one as well, and we pop in there. But if you've got some pressing questions, we definitely encourage you to come here, discord.gg/Algorand, and join our server and come and say hello. We'll help you build. All right, the last piece where you can connect with us is the developer forum. That's also linked off of the dev portal website here. This is threaded conversations, very asynchronous communication. This is a great resource as well for you to search so that you can find answers to frequently asked questions. These are answered by Russ, our team of developers, as long as individuals from the engineering team and as well from the Algorand Foundation. So a great place to connect with the Algo fam here. And we have a YouTube channel. So as you know, this session here will be recorded and will be put up to the YouTube channel for the Algo HackJam. Algorand also maintain a YouTube channel. It's easy. It's youtube.com/Algorand. We have a section specifically for developers here. We do a weekly show called the Algorand Proof of State show, and we have recordings of all of those, and hope that you will join us to learn about what developers are doing in the Algorand ecosystem, how they build their solutions, and see the code, right? So a show for Algo devs by Algo devs. Check it out at youtube.com/Algorand. All right, that's where you need to go. Again, that dev portal is the place to go. One thing that I want to reiterate here that I forgot to tell you about was the search. Whenever you need something, you just start typing it in and it will come up, right? So we're gonna deal with PyTeal. So you want to know a little bit about it. It comes up here. It shows you where you are as well in the organizational structure. If you want to know what transactions look like, you've got your one for building your first transaction. So there's all sorts of great ways to navigate throughout this using the search feature. The last piece that I will tell you is I encourage you to sign up and make your own account. You can you can do that by either linking to your GitHub account, where that can be the registration key management, or you can use your email. You can see that I have published a number of articles here, and those are the things that you can have there. Pretty soon, we're going to have a badging system where as you complete some of the tutorials, you will be able to earn some rewards, and those will pop up there. And all your friends here in the Algo fam will get to see all of the badges and accomplishments that you have made there. All right, Dev Portal, super fun. Let's get into setting up your development environment. All right, so I've been talking about the Algorand Sandbox. What is it? Where is it? Here it is. It is on GitHub, and it is in the Algorand organization and in the repository Sandbox. So if you go there, you will see this, all right? And it will tell us that it has this handy README file, and it says, well, what is Algorand Sandbox? Well, and how do you install it? It tells you all how to do that. Let me just show you what that looks like here. What the Algorand Sandbox is, oh, look at there, build that out for us. The Algorand Sandbox has 4 components, all right? It has a network node. It is also a transaction builder. It is a key manager, as well as a query tool. So what do those components mean? So the network node, this is the ledger. This is the Algorand network. This is where all of the blocks are stored, all the transactions happen. This is the ledger, the blockchain, all right? That tool, we call it Algo D, or the Algo daemon. You will interface with this. There are APIs provided for the Algo node so that you can submit transactions, and then later on, we will use another tool in order to query some transactions. All right, we have a transaction builder command line tool called Goal, and this will allow you to interface with your nodes as well as create simple transactions from the command line. Another key piece here is a key manager. So we call this one KMD, Key Manager Daemon, and this holds private keys for you so that you can use that transaction builder in order to create the transactions and then sign them so that they can be accepted by the Algo D node and then verified and ultimately written to the blockchain. Finally, this query tool, which we call Indexer, consumes all of the completed blocks from the ledger and decodes all the transactions, writes it into a database that you can easily query. And this is what, as a developer, as a dApp developer, you'll use the indexer to connect your web interface to the information in this offline database so that you can understand what has happened in the past, query balances of accounts, know which assets are held, and then populate your user interface so that then ultimately you can build up your transactions within that UI, prompt your users to sign them with their attached wallet, be that the Para wallet using their mobile device or one of those browser-based wallets as well. Finally, your web interface is going to submit that transaction to an API, probably on an Algo D node, and it will be accepted, validated, and then put into the ledger for all to see. So Sandbox takes all of that and wraps it up inside of a Docker container. So all of that infrastructure that we've just described is available just by typing the command sandbox up, and it will run. It will expose then some ports for you to connect your SDKs to. So on port 4001, you will find the APIs for the Algo D node. And on 4002 will be for your key manager. And then on 8980 will be the port that you can connect to the indexer's API and be able to make those queries there. So Sandbox is all about infrastructure and being able to begin developing on your local machine very, very quickly. Sandbox up dev is the way that we want you to start. So let's go and take a look at setting that up now. All right, so we've seen this information, the GitHub site. We want you to come here, clone this repository, and we can show you what it looks like here. So when you come and you clone this repository, it's very easy then just to do sandbox up dev, and this will create a Docker instance, and all of that infrastructure will be prepared for you. So I already have it running, but so let me just show you it running over here. And got it here. Yes, I do. When you run sandbox up dev, what it does is tells you, so yes, here was the command. Oh, where is the command that we ran? Here it is. Yes, right here at the top. So I guess I did sandbox reset, but okay, fine. So up dev. And then it brings it up and it says that, okay, so we're running this version of the Algo node, which is the latest version from stable. And it also runs this indexer. And importantly, it is running a brand new private network for us on our local machine. And it spins this up, and you can see that it at the very beginning, it says last committed block is 0, right? So this is a brand new local network. We call it the SandNet. It is just local to my machine. And every time that I submit a transaction, a new block will be sent. So this is very, very fast. You don't have to wait the normal 4.5 seconds for that block to be processed. That's just too slow for development, even though it's really, really fast for the blockchain world. We want it to go with every single transaction. Another thing that the Sandbox provides, of course, are some funded accounts. So you don't have to go out to a dispenser. These 3 accounts are funded automatically for you. And it even gives you some introduction to running some of our command line tools as well. So we talked about Goal. So we have this hook that Sandbox has Goal installed on it. And they give you a sample transaction here. So you could copy this transaction, which is saying, send some algos, an amount of algos from one account, so the second account from, and then to the third account. And if we run that, paste, and we run it like that, we are going to get a confirmed transaction identifier committed in the 14th round. All right, so I have run a few transactions on this network. And every time that we do that, we can run it again, and we will see that we will get a different transaction identifier this time. We sent the same amount, but this transaction was then confirmed in the next round, the next block, because every time that you submit a transaction, it's writing a new block for us, which is very handy for us as developers. The other thing that you can do then is query the indexer. So they give us this nice curl command, which allows us to hit our local host, right, on port 8980, which is where the Sandbox is exposing the indexer. And we are going to ask the transactions API to give us all of the transactions that they have and print it out pretty. All right, so if we paste this in here, paste, and we run that command, we see the JSON objects of the latest transactions that were sent. And actually, we see right here that this transaction was, okay, so the most recent transaction here was the one that was in round number 15, right? That was the one that we just saw. And we see that the amount was here, and we see who it was from, or I'm sorry, this is actually who it was to, right? And then this is who it was from. And we see that this is the signed transaction, the signature. So again, the KMD, the key management, Damon, took the key out of its wallet and used it to sign based on the sender's account. All of that is contained within Sandbox, and you can run various commands from the command line if you want, or you can use your SDK to connect to and to connect to that infrastructure using some clients. So we'll see that in our code momentarily. All right, back to our presentation here. So enough about what Sandbox is. Let's talk a little bit about our SDK. So on the developer portal, we have Python, JavaScript, Go, and Java SDKs provided by the Algorand engineering team. We also have a link here to community provided SDKs, which will include C#, Unity, Rust, and other SDKs if you are interested in doing that. Today, we are going to use the Python SDK. So in order to install that one, you simply do pip install py-algorand.sdk. That will download the latest version of that. If you want to do the other ones, make sure you follow this QR code and select the SDK of your choice. The installation are very similar. They come from whichever package manager is associated with your environment. The next thing that we'll talk about are the integrated developer environment. We have a number of them provided by the community. I happen to use Visual Studio Code, right? So this is you can use whatever you want, right? But this is one that I happen to use. My recommendation is that you come over here to the extensions and you search for Algorand, and you will find that we have the Algorand Visual Code extension available here. And as long as you're there, you could also install the Reach IDE as well. I know you saw JP give his talk on building with Reach last week. So get both of those installed. That'll make your life a lot easier for doing code highlight and so on as you go through and build. So, right, that I think shows you everything that you want to do related to getting an IDE set up. Again, I guess I'll go back and just show you that we could follow this link and we could see some of the other IDEs that are available. Skip down to IDEs, right? So we have a web-based one. Algodesk is a very nice one if you just want to quickly try to create assets or create some transactions. The AlgoDia is another lovely one. This is an IntelliJ plugin. Great for building transactions and building smart contracts as well. And then, of course, we have seen the Algorand code extension as well. All right, let's now take a look at our main focus here, getting into PyTeal and taking a look at this ABI demo. All right, I think we need to start with PyTeal itself. So PyTeal is a language binding. If you are a Python developer and you're familiar with the syntax, you are going to really enjoy writing PyTeal, because what it does is allow you to create expressions in Python, and you just simply define your logic of your program, and it will then assemble that into and be compiled into the Teal program that can then be installed as a smart contract on Algorand. So we'll see how that all works. PyTeal is very well documented on the Read the Docs website. So if you go to pyteal.readthedocs.io, that's where you'll get the best documentation. To install it, you simply do pip install PyTeal. The Let's see, what else do I want to tell you about Python? Okay, PyTeal it's also referenced in the Algorand developer portal as well, so you can get to it there, and we give an overview of what it is. But we have lots of links that will actually come here to read the docs because we know that Python devs expect their tooling to be documented there. So we're meeting you where you are. So make sure that you get your pip install PyTeal going. And the thing that we are going to focus on, we saw it already, but it is one of our many demos that we have available on GitHub. Our organization name for the DevRel team is Algorand-DevRel. And if you just go there, you will find a whole bunch of interesting demos that you can try out. This one that we're going to do is called the demo ABI. And if we jump to the code for that one, I guess I have it already loaded up in my IDE here. So again, what this one does, I guess we already saw what it is, but let me just remind you that this one is going to create an application binary interface within the PyTeal language, and it will output a JSON file that represents the definitions of those methods, and then you will be able to take that and use that within any of your other SDKs, or as you saw, be able to use that to define a user interface as well. So, what are the contents of this? Well, let me note to you all that this is kind of some bleeding edge code right now. So what our colleague Ben has done is to use a very specific version of our PyTeal environment and our Python SDKs. So when you check out this code, you are going to have to run pip install requirements.txt in order to actually pull down the feature ABI branch, because there's an open PR to get this in there. The next release of our PyTeal will include this. You can run it now. Just make sure that you follow the instructions in this here. All right. So what's included in here are a few different files. Importantly, there is a manage shell script, which is going to help you set up the copy all of the files that we're going to define in our contract, and get them installed onto the Sandbox, uploads them, and then it ultimately returns back to you the identifier of the contract that you just created. And then it's going to output, so when we compile this contract code, it's going to output both the teal code that will get uploaded, as well as this JSON object that we can use in our other SDKs. All right, so let's start figuring out how we want to actually write a contract using PyTeal. First thing that you've got to do is you have to import the library. So that's as easy as just saying from PyTeal, import it all. All right, so quite easy. As I've said, that PyTeal is really an expression builder, organizing your logic. So this is what that looks like. You know, it's straight up a regular Python code here. So we're going to set this variable is creator equal to an expression, and this expression says as long as the transaction's sender is equal to the global creator address, which is another field within the transactions. As long as those are both equal, we'll take the result of that, whatever it is, because this is going to be taken in real time. Set that is a creator. So that's how that expression is created there. What we're going to do next is to use a new feature called the router. And what the router is designed to do is to make it easy for you to break your program up into various methods and various components. So we have some handlers for what we call the bear transactions, and then we also have these various methods that you can define. So we're going to take a look at those. We saw here's the add one that we actually saw in the user interface there. But first of all, let's take a look at this the router and the bear call actions. All right. So first thing that you're going to do when you create your router object is you're going to name it. So we're just going to name this one the demo ABI, right? And then what bear calls are all about are our handlers for each of the different transaction types that we have for application calls. And what we have there are the no-op, which is the standard application call. We also have ones for updating the application, deleting the application, and then clearing the state as well. So these allow us to define expressions for each of those different possible transaction types that could be sent. So what we see here is for updating and deleting the application, we are simply returning is creator, right? So we set that expression earlier, and what would happen is it would return this address always if the action type is on complete or update. What that means then is that you, as the creator of this application, your address would be defined in there, and you would have the ability to update your application or delete it. Whereas somebody else who came with a different address, when this smart contract would execute the update application section, their address would not match what was passed in as sender, and therefore the value would be false, and therefore the contract would fail. Therefore, they could not update the code. So that's the way that works. And then for the create only, we're just going to approve it, right? Whoever creates the application first, they can do it. And same thing for clear state. We actually don't have any state here, so it doesn't really matter. But that's bear calls. What is more interesting is down here where we start defining various methods here. So we use this decorator called @router.method, and this allows you to handle well, first of all, define various method names and then handle those, and then you're going to define your code within each one of those. So what you have to do here is that this is going to automatically generate the method signature, and you will define that as first of all just saying, well, what do you want to name your method, and then the next section is going to be what are your input values, and then after that are going to be what are your return values. And so in this example here, we'll take a look at add. So, well, let's just do this here first. So focus on this. All right, so we're going to name it add, right? And we're going to have two uint64 values. First one is called A, the second one is called B, and then the output is also a uint64. All right, so we're going to define this expression this way. And we give a description that says sum A and B, and it returns the result. All of those are uint64s. So what is happening here is that we get this A.get and B.get to return these expressions, right? So we've got the documentation here. I won't read through it. The important part is here's the actual code. We have to return an expression for this method. And what we are going to do is we are going to return this expression, which is A.get plus B.get. All right. And then, of course, we are adding those together with the addition operator here, and it will then return that code and build the teal that defines all of these pieces here. You don't have to worry about, what is all of this ugliness here. It takes care of writing all of this for you, but we do see it here. If this is the method named add, we see how we have defined it here, right? The two input values, A and B, right? It doesn't have that, but we know that's what we've called them. And then the return value here. And then if that's what it would be, then it would branch in the code to do that. So then if we went and found line 127, it would say that this is the no-op and it is the application ID. It's not equal, right? Assert. All right. So we are looking for loading application arg number 1. And that's the A value that we saw. We're going to convert it from bytes to int. We're going to store it. And then we're going to load the second value, B. We're also going to convert it, store it. Then we're going to load them. And then we are going to call the subroutine add 0. And ultimately, when we look at that, Control C, find, go to call 0. And then it's going to actually add those together, and then it's going to go back, and ultimately it's going to return that value back to as a result of executing this transaction. So that is what that one looks like for add. We have lots of different examples here of various mathematics ones. So subtract, multiply, divide, modulo. We also have one for doing some string manipulation here. This one is called reverse. So this one is taking in a string and it is outputting a string, but what it is actually doing is a little bit more exciting in terms of it's taking whatever string you have in, and it is iterating through a loop here to load those, do a buffer, store it temporarily, and reverse the order of all of those characters. So if you type in Ryan, the return value is going to be my name backwards, right? That one does string manipulation. There is another one in here to concat a bunch of strings together. So this one actually takes an array of strings and it will output just a single string. There is, let's see, sum the array. There's another good one here that I want to show you. Minimum balance. Okay, so here, this is a good one. So this one returns the minimum balance for the passed-in account. So the first value that you would pass into your application arguments is going to be an account type, and it is going to return a UN64, meaning that it's going to return the balance that that particular account has. And so what that looks like is the return value for this method says, well, give me the minimum balance, and we're going to set it equal to the account's parameters minimum balance. And then we simply set the output value to minimum balance.value. So PyTeal is very concise to write, and then when it compiles down, it expands that into the teal that is necessary for the Algorand virtual machine to interpret and be able to use. You can also do a void, so you don't have to do one that returns anything. So here's an example of this. It's just taking in a UN64, but it isn't doing anything, right? So that's just a quick demo of that. There's another one that does a transaction. So this one actually creates an inner transaction so that the contract itself sends a payment transaction out by calling this method transaction test. All right. Once you define all of your various ABI methods, you can then compile those down. And so we're just simply defining where do we want this file to go, and or the files to go, what is our OS path. And then we do a simple router.compile program, and we give it some some parameters. What version of Teal do we want to do, and do we want to have some optimizations for it? Importantly, what the return values for this method are three things. There is an approval program, a clear program, and a contract. And what the approval program is, that was actually what we were looking at before, right? So this is the Teal that will be executed every time that somebody calls this particular application identifier. The other thing that it returns is a clear program, which is a simple program that if the user calls, they can clear their local state. In this case, this example doesn't use any of that, so we can largely ignore it. And the last portion is the important bit, the ABI contract file, this JSON file that is returned, that then has all of the methods defined in there. So as you recall, we had named our router demo ABI, so that is here, and then it has all of the methods that define our ABI. So here we have our first one, add, and we see that it has the two argument types here of A as a UN64 and B as well as the return value for this one, which is also UN64, and there's our description, right? So it built the JSON file here based on our PyTeal that we defined way up here, right? Right here, right? So there's all of that here, writing in Python, getting it exported as a JSON object. Now you can take this and consume it within any other SDK, or take it over to another tool and build a user interface. This defines how anybody needs to interface with our particular application. At the very bottom, you would fill out some specific pieces about which networks it would be on and what would be the identifier of that. So this is very generalized because we haven't yet deployed it. So let's take a look at deploying it. And in order to do that, we have this handy shell script here called manage. Manage is going to use the sandbox in order to take those three files that we had and push them into the Sandbox environment. You may need to change the path where you have Sandbox installed. I happen to have it installed here in my home directory in the Sandbox here. If the script doesn't work, make sure that you check that out. You may have Sandbox installed at a different location. What happens here is it's going to go and look at all of the accounts that are in that KMD wallet on Sandbox and grab them and use the first one as the creator account so that it can then take those files, or what's then going to do is it's going to execute the contract.py file, and it will take the resulting files that we saw here, and it will copy them up to Sandbox, both of those, and then it will, if you give it the create command, it will actually create the application here. So it does another goal command, and it does an app create, and it's using our creator that we defined up above here in shell, and it defines our name. It takes those programs that we just saw there, and then it defines what this application needs for storage. It doesn't need any. And then ultimately it tells us what application ID we have, because we will need to know that when we are writing a user interface or when we are calling, when we're generating transactions so that we can call that. You could also update it as well. If you change any of the code in contract.py, you would call this manage with the update command as well. So here we go. So we are going to just run this. So manage create, and it is now going through and running the Python to compile our program here. And we see that we have now successfully deployed it. It returned us the application ID of 36. So we can then use that when we are over here in Python ABI. So now that we have deployed the application, we actually have the ability to use some sample applications in one of the 4 SDK languages where we're using Python. So let's take a look at what this ABI Py is. This one is, so in Python, here's how you use the Algorand SDK. You can make all the connections here. Importantly, you're going to import the various clients, the transactions, the mnemonic, the accounts, all of these different components here. We need to create that client. So we are using our local host on port 4001. So that's our sandbox, and we are making a client connection that way. Now we are going to ingest that contract.json file that we saw, which defines our method signatures, and we'll read it in. And then we want to process that, get the names of all of those methods. And then ultimately, we're going to come down here and compose a series of transactions. So we are going to use the atomic transaction composer, and we are going to define, what do we got here? 5 or 6 different transactions here. So we are going to that ATC, we are going to add a method call, and we are going to give it the app ID. Ooh, that reminds me, we got to change the app ID up here. Let's see, where did we define app ID? Oh, app ID is written to a file. Yeah, so we actually read that, so we don't have to change it. It is written to a file locally when we run this. So we'll get it, and then which method are we going to call? We're going to call the add, and where are we going to send it? Well, we're going to send it 1 and 1. So we know that that's going to add 1 and 1, and we expect that the return value is going to be 2. So we'll see. Subtract, multiply. Also look at this. QREM, which is the quotient and remainder one, that actually returns a tuple. I should have showed the code on that. We'll take a look at that towards the end as well. And then we have some other calls for doing the reverse, right? So this we are going to call the method reverse, and what are we sending it? Oh, look at, we're sending it the reverse of successfully reversed. All right, so that's the backward string that we are sending it. So hopefully we will get the return value as successfully reversed. And we have a couple of other ones as well. And then we get to the end of that, and the last thing that we do is execute it. So we're going to take that set of transactions, and we are going to execute it using our client, and we are going to wait 2 blocks until we can get a confirmation, and then we will read the results from that completed transaction, and we'll see what they are. So we will for each of those, we're going to print out the method name, and we are going to print out the return value. So let's do that now. All right, so I'm going to run python abi.py, and we are going to see what it does. It executed all of that code rather quickly, and it returned here. So add, right? 1 + 1 was 2. I don't remember what the other ones were, but the other ones we talked about, right, was the string manipulation one, where it was successfully reversed. So we know that we had passed in DESD, right, and it successfully iterated through that to do that. It sent a test transaction sending 10,000 micro algos to another account. And then there was the minimum balance, right? So the account that they sent it to, they went and queried it and found that the minimum balance was then 100,000. That is the way that it works for calling a whole group of transactions. So that's from the command line. You can do that using goal as well. You can create your own from the command line, or you can simply create them one at a time as well using using, well, you can either use an atomic transaction composer, or you can just use the application call transaction builder as well, and it will look very similar to this. All right, the last thing that I want to show you is making a quick UI. So one of our community members, Fiona, made a wonderful user interface for consuming those ABI JSON files. So this uses the ARC4 specification. ARC is Algorand request for comment. And so we have a definition of what our ABI should look like, how they're formatted. Obviously, we went through and saw what that is. So she made this wonderful user interface here that consumes that file and then builds out the user interface so that you can quickly interact with it. So this is where you can go and see her code. We're going to, and then she also has a live demo running. So let's go and do that. She called it Wasabi. And what we are going to do is make sure that we paste in our code here, right? Take all of this, copy that in, and then paste it in here. Control Alt, delete, paste, submit. All right, and then we have to configure our what we want it to connect to. So by default, it's going to connect to Sandbox. It gives all of the information here. And then we need to define the application ID that we want to use. So we want to use current use, no, you use 32 self-defined app ID. This is what I'm looking for here. I want to do 36 because that's the one that we just made. So we are going to do current. Yes. And then now that we have configured our interface here and passed in our method signatures to it, it automatically generates all of this here for us. So now we can do something fun down here. So if we do this quotient and remainder one, so it takes two UN64s, right? And what it's going to return, though, is going to be a tuple. It's going to send us two. So it's going to send us both the quotient and the remainder when the result comes back. And sometimes it doesn't want to do something for me, but let's try the string manipulator, right? So we see the reverse, right? I typed in Fox and it came back OXF. So that's nice. And one more subtracting. Let's try to subtract 1 from 10. Hopefully we get 9. As you'll notice that each one of these is a different transaction ID. So yes, these are actually going to the blockchain and being returned. We could then take a look at that transaction ID for Quebec Mike. And if we were back at our Sandbox, move you out of the way. Oops. Back here at our Sandbox, and if we did that curl command one more time, we should be able to see that transaction ID as the very most recent one here, right? So for Quebec Mike was our most recent transaction. And what we can see is when it was completed, this was a no-op call. And we should have some application arguments here. We see that it was application 36 that we called, and the application arguments, we had 2 of them. These are the values that we sent it. Those are in base 64, but those are the numbers 10 and 1. All right. I think that we have successfully shown you all of this. So where? Right, we have it available for you here. All of these slides are posted here. We have them as a PDF document. Hit that QR code and get them, and then you can go through, follow along, do all of those things, clone those repos, and get yourself building. So I really thank you for joining us here, participating in the Algo HackJam. I look forward to connecting with you on Discord or on Twitter or anywhere that you are building. The Algo fam welcomes you. Thank you very much.
All right. Thank you, Ryan and
Yeah, Brian.
Russ.
Yep.
We had a couple of questions. I
Great.
believe Russ has answered.
Yeah, well said.
Covered that.
All right, wonderful. All right, well, have fun building an Algorand. We'll see you next time.
Yeah, thank you so much, you both.
Bye-bye.
Okay, thank you, everyone. Goodbye.